Again, you can go over it a little bit if you need to, finish up what you're doing, but we expect that goes into your timing for questions, which we have another 15 minutes, so keep that in mind, because we'd like to keep scoring it if we could, right? And so, I think that's pretty much it. We have a few folks back there in the back, I see, yep. So, if we see them kind of give you all any cues or anything, we'll kick them out. If you want me to, I can kick them out right now. But welcome everybody back there. I guess y'all know the rules. How that goes.
Not our first rodeo.
Yeah.
And let's see. So introductions, real quick. My name is Patrick Barrow. I am work for Oceaneering. Been working for Oceaneering, project manager for about 30 years this year. I've supported this competition for 23 years. So I've done it since 2003. I guess that's right. And I tell everyone again, I learn something all the time here. It's really fascinating. Neat to see what you guys do. Always right out there in the front, cutting edge. I work in the new product development group at Oceaneering, so I get to do a lot of new things, building design stuff. I've done a lot of Oceaneering. I've worked at NASA for Oceaneering for about 15 years. So the oil and gas the last 15 years. Before that, I worked in aviation, I worked on aircraft, I fly airplanes too, so kind of need all that, builds a different kind of aspect. You learn a lot of learning things, I work with my hands, and this whole competition kind of gives you all that wrapped up all in one. I think it's very fascinating, very neat, so a lot of opportunities for it, I think. Oceaneering's always looking for the next employee, by the way. So, Libby will probably pick someone out. Anyway, so that's enough about me.
Hi, I'm Libby Raymond, so I'm also part of Oceaneering. I've been there for almost 15 years, and I'm the Deputy Director of Engineering at OTEC. So that's about 300 engineers that are all helping to make unique underwater vehicles for U.S. Navy purposes. And it's my 5th year, judging as here at me, so it's a delight to see all of you.
I'm Terry Ayers. I'm the computer science department chair at Ball State Community College in Huntsville, Alabama. I've been teaching there about 30 years, programming, networking, cybersecurity, all those things. We do a lot of ground-based robotics and the aerial drone competition hosting at our college. We actually got 8 national champion winners from our college, so I'm quite proud of those over the years. So looking forward to seeing what you all bring to the table.
All right, big breath. All right, go.
Alright, so first of all, we just want to thank you guys for being here today. Taking time out of your lives to sit here and watch us present. We appreciate it so much. Second of all, we'd just like to thank a couple of our sponsors before we begin, including CrackerNav, iFixit, Quanta, and Aspen Utilities. Second, we're all going to introduce ourselves. So I'm Gabby Anguiano. I am the mechanical lead.
I'm Joe James Sanchez. I'm the electrical lead.
I'm Robert Thuder. I'm a mechanical team member.
I'm Justin Yoakum, and I'm the safety officer.
I'm John McSwiggan. I'm the pilot.
I'm Adam. I'm the software lead.
I'm Nicole Mona. I am the media manager.
I'm Mark Thompson. I'm the CEO.
This is Mako. This is actually our 3rd iteration. It's been relatively similar in terms of its overall structure, but as we've been doing this competition over the past 3 years, we've had a lot of improvements. But at its core, Mako is designed to be very modular, very robust, and very easy to expand and adapt to different sorts of tasks. The biggest sort of notable feature on this is the fact that it's very large compared to a lot of the other subs in this competition, and that primarily comes down to the fact that we have a lot of our thrusters internal, and that allows us to avoid breaking off thrusters. Say if we lose control of it, hit a wall, something like that, it allows it to be much more robust and damage tolerant than a lot of the other subs in this competition. We also have a very large enclosure in the center. This is 8-inch diameter acrylic, and inside this houses a lot of our electronics, which allows us to do a lot of very cool things.
So moving on to the electronics and software, we start out with, we take in 48 volts at 20 amps maximum. We'll get into why that is later. But then that is setting up 24 volts for the thrusters and 12 volts for the computers and 6 volts for the servos. One important aspect is the selection of 24 volts for the thrusters. We did that because we wanted to have a balance of extremely high currents, so our rating is about 60 amps internal. On the 24 volt bus, it'd be even higher if it was 12 volt, and lower if it was 48, obviously. However, the P200s are more efficient as voltage decreases. However, despite this, we decided to go for a voltage that's outside of the rating because we tested these thrusters at 48 volts for 24 hours straight in a test tank to verify there'd be no degradation. However, with this high voltage, we have to limit our power and software. And our software is ROS2 Humble, and which was selected because it goes along with the highly modular and highly serviceable system that we produced here. And within ROS, it allows us to get a lot more tooling to provide more extra features, particularly in terms of safety.
Yeah, so on the safety side of things, we obviously use the MAPE required thruster guards. These thruster guards actually came from another team, it was their design. With this design, it allows more efficient flow through while still meeting the safety requirements for I-20. As was stated earlier, all of our thrusters are internal, which again makes it harder to actually access the thrusters for a diver in the water or anything along those lines. So, during the safety inspection, it was actually brought up that we should have feet on here to not damage the bottom of the pools. So in a matter of like 2 hours, we got these designed, printed, and installed. So with that, for protecting the bottom of the pool, on the personnel safety side of things, we have a strict regimen that we follow. We always wear safety glasses on deck. We have our JSEA, which states all of these requirements, who has to check off on them, who it specifically applies to. From there, during our testing, not at the competition, so back in Florida, we follow a pool testing standard operating procedure that was written by us. This outlines how we want everything set up for the pool, who we have to notify. We submit it to the actual pool, make sure they're aware of what we're doing, why we're doing it, how long we'll be doing it, what kind of personnel they'll need, what kind of restrictions we need them to implement, whether it be we can't have anybody in this lane with us, we need 2 lanes buffer, whatever it might be. So with that, we protect both ourselves and other people using the facilities.
Another form of protection that we have is our remote arm disarm, and that's what transitions us into our overall pilot interface. Over here, you see Logitech's X56 HOTAS. This is both flight stick and throttle. A multitude of buttons. This gives us a lot of customizability. It gives us a lot of different ways to control the submarine. For translation, it's pretty simple: forward, backward, left, and right. We can yaw by rotating the stick. We do depth control using this knob over here. Rather than using the throttle, which we had originally found, using this allows us to be much more precise and allows us to be, that's the right word, but just a lot less variation if I'm trying to move to a certain point, because rather than having this be in one position and it's constantly going down, I just have a set point here and I can just hover in that exact depth. We use this knob here to open our gripper, which is actually very useful for much of our tests, as Rob will get into soon. And another big part of our pilot interface is our actual Dell Tufto. So on this, you can see, well, they're actually not showing the camera feed right now. We have 3 different cameras on board. These are deep water exploration cameras. So we have a front-facing camera. We have a side-facing camera on this adjustable mount, so you can either look down, up, or to the side. We also have a vertical one, which you can basically see where you are right now, and that allows us to see directly below the ROV. We also have this model here, and that actually shows the orientation of the ROV. If for whatever reason the camera's using not allowing you to see really the overall orientation of the robot. And over here we have various set points. We can see the depth, we can see various angles of pitch, yaw, and roll, and that once again allows me to have excellent controllability. And then we want to go into
Yeah. So our sub uses a variety of different tools for different tasks. We've mostly split all the tasks into either interactive tasks or visual tasks. So for the visual tasks, we obviously have the cameras they can go in different modes to interact with. And we have a measuring device, which I don't know if it's with us right now. We have, for some of the different measuring tasks, we have this measuring device that has 8 different points on this cube. that we can move and set down in front of whatever we're measuring, and we can use the comparative, since we know the fixed distance, we know the distance between all of those points, we can use that to measure the larger scale objects. And then for different other tasks, like the spinning one, we have this specific spinner right here. We have our grabber that holds us for most, or that grabs onto most things, most of the tasks that require grabbing. We also have a tail hook down here that can hook onto different things, like the crab basket, we can grab onto that, and then the different coral stars, we can grab onto that. We have this spool right here that attaches the gripper for the anchor buoy that we can latch, yeah, which is a quick release, which we can latch on, let go, and then it'll stay on the bucket, and we can spool it back up to land. Yeah. So in normal, or in ice environments that we'd be in Newfoundland, there are a couple of important things that our sub would need to have to be able to operate well. First of all, as we said before, we have a very rigid frame, so any ice or debris that's in our way, we could just, we don't have any risk of damaging our sub, especially with the internal thrusters. We have lights, we have headlights in the front that can help us in under ice conditions where there's not any natural light, so we can get as deep down as we need to. And then our sub is also very maneuverable and very stable, which can help a lot when there's a lot of strong currents deep underwater, especially in the cold environment.
And when it came to task planning, as Rob mentioned, we split it primarily between interactive and visual tasks. So in the food tank, as we're seeing, whether it's identifying invasive green crab, or if we're looking at iceberg plotting movements, we need to be able to see various types of markers or defined shapes underwater, and that is ultimately done with our camera system. With our engineering basin, we're able to see a lot more interactive tasks. The gripper is extremely useful for that. And actually just in our fluid tank run, which we just did, is very useful for our coral and basket stars, that collection there. But it's going to be very useful for a lot of the other tasks that we can do, whether it's the Hollywood subsea territory, clearing and moving power connectors, dealing with fishing gear, or actually the current orientation. What we have is a clip for the buoy anchor task. We have that which can slot right into our gripper, and that is essentially a compliant carabiner that fits over the hole, and that can spin back out.
So, moving on to some of the challenges that we faced with this ROV was that I mentioned the 24-volt bus for the thrusters. Well, one of the things with that is that was one of the first components we purchased for this ROV. And we tried to stay simple with reasonable amount of off-the-shelf parts so you can get a working vehicle as quickly as possible. And unfortunately, we made the mistake of buying it on Amazon. Our sub has always been sluggish, and we figured out while measuring our full load amps that we were only drawing 12 of the allotted 30 that we could, and we traced it down to our DC to DC converter through taking a multimeter and looking at the voltage drop on the DC to DC converter, and then we realized that went below our minimum, and that would cause us to turn on. So to try and fix that, we in-house designed a power board. It would run at 12 volts for higher efficiency, and one of the challenges was we had switch-on power supplies that we used basically PWM to approximate voltage, but with that, it produced a significant amount of noise on the bus, and that interfered with the logic levels and prevented ice-grid-C communication, which is what our depth sensor uses. So the reason why this happened is we just ran out of time, and we had difficulty in finding the necessary very small capacitors like tantalum and ceramics that would deal with the heat frequency switching noise. And we focused on the larger capacitors that would deal with more aggressive swings in voltage. So that was one of the things that unfortunately had to switch, like 2 days ago, back to our old PowerPoint design. And, yeah, and moving on to, with this change, we had to also redo a lot of our software to make sure that we could have the proper PWM offsets for, not going over our current budget.
Yeah, so, as Mark said, that's part of our ROS 2 stack. So our ROS 2 stack is configured by launch files. It allows us to, in the field, if needed, and during full testing, change our thruster limits, as well as retune our PIDs whenever we change our thrust limits. I mentioned the thrust limits. Our ROS 2 stack is fairly straightforward. We have an IMU that feeds our PID loops. These PID loops we have are for our full 6 degrees of freedom. Additionally, we also have a translator, which allows us to keep, do a coordinate transform for the, translating the current orientation of the ROV vehicle to the desired thrust angle necessary to maintain, the position that we'd like it to be in. Additionally, this year we implemented, some of the issues we encountered were related to the cameras, randomly cutting out, due to some unresolved issue as of now. However, we found that a solution to this problem was reinitializing our video pipeline. So as part of the pilot controls, we had functionality for him to be able to restart those on the fly, on demand as needed, as well as toggle between our different cameras. So currently he has 2 camera views, as you can see over there. Those 2 camera views being this primary and the second accessory, switching between top and bottom at the pilot's will. Just switching between these 2 toggle switches allows him to do that.
One of the tasks that were also did for software was the crash test, and with that we had to get the amount of invasive crabs that are on the sheet, and we basically had to use the NCV or any sort of means to count that. Anyway, so basically what we used is that we used a custom-made Neola model that we trained over a data set of roughly 250 images, and with slight variations in them to try and increase the data set, and we managed to find the crabs.
Yeah, so with all this technical knowledge, obviously we do have some soft skills here at Wakefield that we like to practice. Since we drove here, we definitely work a lot on communication, and like a lot of teamwork, especially under pressure. We got a lot of that. We also do have a lot of graduating seniors this year, so we definitely had a really major focus on inter-team mentoring and like a lot. Raise your hand if you took up a mentorship role. There you go. They did a lot for us. We had so many young members learning things. Just all their wisdom that they had passed down to us. I personally did some work with the pilot interface and with working with various electronic and mechanical parts of the ROV.
I, for example, took a lot of mentorship from Mark. He's usually the one initializing the runs at the pool, debugging whatever code isn't working, so I learned a lot from him to be able to take on that role next year.
Thank you.
Okay, good, all right. Yeah, good deal. So you drove from Florida?
Yes. Wow. What is that, like 30 hours?
42.
About 5 minutes. Yeah.
40?
42.
Yeah.
Oh my.
Not including the ferry.
Not
Why?
It's significantly cheaper.
Yeah.
Cheaper?
Yeah.
And also just fears of shipping tomorrow.
It was fun.
Just saying.
We've heard about TSA that time wires for other ROVs with one rescue.
You'll do have to drive back.
Yes.
That's a problem for next week.
Maybe you just want to stay. It's up to you. Wow, okay, well, good stuff. I have one question about safety. There was, and maybe I heard it wrong. You said your standard operating procedure that you use in Florida was, and you did this. So, is that any different here? Well, why, it seemed like you didn't do it here, but you do it there.
So the JSEA is essentially not a modification, but an update on that,
Okay.
the one that we use in Florida. The main difference is that for that is cold weather gear.
Okay.
Obviously in Florida, we don't need jackets, gloves, hats.
Okay.
So that was really the main difference, yeah.
Okay, all right, good. I was confused.
Yeah, exactly.
Well, you just threw safety away when you left Florida.
Usually it's the other way around.
Yeah.
So what happened? I feel like you
Right.
guys did your electrical design and then changed everything 2 days ago.
Yes, correct, yeah, so that was a design oversight on my part. During the fall semester, I sustained a pretty massive injury to my left elbow, requiring a massive we had some 2 plates, 13 screws, and in that case, designed the power board, with some oversights, unfortunately. So that will probably require a redesign in the future. But what we discovered is that it's a fairly straightforward procedure to repair it, or to redesign it rather. It's just adding additional ceramic capacitors. So if we can find the proper size capacitors, we might be able to even use the current design. However, the footprints are quite small. So finding the adequately sized capacitors at that footprint size may not be viable.
And so the main issue we were having was, so like our depth sensor wasn't initializing, if I understand that correctly.
Yeah, and Mark mentioned the voltage swing. That was a 3.5 to 4 volt peak to peak on a 12 volt rail. And even with the capacitors that we had on hand and were able to get flown in Florida on from other projects we had on board, we got that down to around 2.5. And even for the USB communications, that's our processor goes from USB to I2C. Those USB communications and the I2C logic level, if that 2.5 to 3 volt voltage swing still exceeded whatever logic level it had, and would just cause corruption.
I'll bite. What's the guitar?
Somebody's gonna guess.
We'll ran out of time.
That's fine. So, this is a Guitar Hero that we found at our lab. And on a just hasty day, they decided, what if we use it to control the sub? It currently runs out of just a very big C++ file. Yeah, made in pretty much a day. Right now we're currently working on translating that into Python and multiple files to make it more organized, more easier to understand, easy to change if anything doesn't work, and just easier readability. We're currently working on making sure that all functions work for the collaboration task on Saturday. We really want to use it for that. Just a fun little thing. It's also great for just marketability of the club and outreach. We've used it in the pool sometimes, and people always come up and say, what is that? And then here, actually Made ROV posted a picture of it on the Instagram, and everyone freaked out about it. So I think we did a great job at it. It's just a fun little project that we wish to hopefully have perfected, or at least perfected enough for Saturday.
It also helps out in open houses. So like a lot of open houses, we do demonstrations showing our greater organization has another team that also has autonomous underwater vehicle. So we have both of those on display doing cool tasks, and occasionally we allow other people coming to visit to pilot the submersibles. So part of the allure is affecting.
And they can also
the underground.
pilot the Guitar Hero.
Yeah.
It's always fun.
Mm-hmm.
Pretty cool, pretty cool. That's it. So what, you said something about communication on the way up here, right?
Right.
What did y'all learn? What was your lessons?
Lessons learned.
That you
Lessons
learned
learned.
interpersonal type.
So most are morning people, so most are.
Yeah.
So that was fun. I think learning a lot about, how we work as people individually, like what we all need to function as a group. The kind of emotional intelligence for that, especially being trained in a car for 4 days. You really learn.
You learn who your friends are.
Yeah. It turns out some of them.
4 of us have been roommates in college for the past 2 years, so we've sort of worked out.
We worked out through that, right?
Yeah, but then, you mix in other people, then that upsets that again, we gotta get back to, good solid ground.
We gotta figure it out.
Yeah.
Oh, yeah.
That's really, it's really important, especially in the field where you have high level technical type, right? You're usually working with atypical personalities. And I would prefer to hire someone, I've hired several engineers in my lifetime. I prefer to hire someone that can work together with others than a doctorate that can't work with anybody. You will get a lot more done, and I know you've probably heard it before, as a group than individually. So it's good that you learn on that. Work with the team.
So what one thing would you do differently about your ROV if you had, say, a month to work? What one thing would you do differently? One thing. Just one.
When we did have it, so, the depth sensor was the only thing that didn't work on board. We did get the full load amps, power draw, on the actual thrusters, and that really unleashed a lot of power for us, allowed for a lot more creativity in our movements and a lot quicker getting around the course, so that really would have helped us out today.
Sometimes you can solve the problem without solving the problem. Did you think about just using a different depth sensor?
We attempted various ways of using the same depth sensor, but no, we didn't try using a different depth sensor.
I did consider it, but one of my concerns was is we really figured this out on the road. That was going to be a real problem.
Yeah.
So the main issue for us was getting another one, but also being aware of other depth sensors like it on the market that are just kind of plug and play. We didn't want to deal with the extra integration time potentially.
I do want to go on there. She looks very pretty. How did you guys do in the pool?
Actually, very good.
Did you do well in the pool?
Pretty good.
Yeah?
And,
As expected?
Yeah, I can. We were fine.
Let pass on the table on board.
other than that, that would
You
be
know,
the
that's
status
not
quo
bad.
for the other bands.
Is the vacuum on?
No.
No.
Hold on.
No, it's in the fall. Do you have a private pool? For more of our.
So how do you said you could put
Yeah.
Just a pin.
Oh. Wow. That's
So-
easier than I expected.
I saw bolts, that's
Yeah.
it's gonna take a while.
Screw it on.
Just up and up that side.
We thought about doing a motorized version, but with as expensive as underwater structures are, it's much simpler to do that.
The E-Tray coming out is very helpful for repairability, especially with electronics, which I think is something that's basically, like, that's the only reason why we were able to do all the power board switching and all that.
Yeah,
Because
yeah.
we can just take all the electronics out right there, and we have access to every single component.
Yeah, I think we overhaul our electrical system in an hour, I believe.
Yes. Including switching on tether. So we had some pretty bad issues at the hotel pool last night, or early this morning, I guess, with the wireless feed cutting out randomly. After marking some throughput tests, we measured a less than 50% of our possible throughput when our thrusters were engaged. And that's because our tether connector was going through all of our noisy ESCs. So we switched it to our DC side, and that revealed close to 80% of the theoretical throughput.
Yeah, we went from 40 megabit, which was not enough, to 60 megabit, and that was just the right amount that we needed.
The feed was basically flawless when we were doing that one day.
So I don't know that I've ever seen anybody, or maybe it's just because it's so clean that I can see it. You just have like a straight power plug and you're running your HDMI up your tether?
Oh, we have no HDMI, it's just Ethernet, it's all through terminal.
Oh, are those USB-C?
These are USB-C.
Okay, I thought it was HDMI.
I don't know if you guys have heard of it, but the Blue Robotics Fathom takes our H and Ethernet, sends it to 2-wire and sends it up.
I don't think I've seen one of those here yet. Is that new?
It's been around a little bit.
I think we'll get on ours. I think it's a little more expensive, but we wanted to get something that's, rather than like an Ethernet cable, we wanted to get something that we know would work since, penetrations into the ROV are critical, and we might as well go with the proven tether solution.
You guys have very like minimalistic, sleek tooling. So, is there a lot of prototyping that went on with
Oh,
that?
Yeah.
Oh.
That is 3 years of evolution for the river at least.
Okay.
Justin, want to talk about it?
Yes. This is the first year we've actually had the gripper working. So, we had one for the last 2 years, but each time something would go wrong.
We like
ended up
progress.
just using it, plug off of a pegboard instead. So, yeah, this one, we finally went with an off-the-shelf, waterproof servo. In the past, we actually tried using another off-the-shelf waterproof servo, but apparently that comes with a hole in it, they don't tell you.
Yeah.
So that one was fun. But yeah, so got the standalone servo and then built all of the actual pouches and claws around it.
Yeah. One of the fun challenges of that was, we needed to make sure we didn't burn out the servo while we were grabbing onto something. and we basically implemented a shaft coupler that allowed for a torsional mismatch between the input shaft and the location of the claws. And we ran into a fun issue with that where traditional 3D printed PLA, it turns out it has terrible fatigue properties. And I've been developing a FDM, or a different method of printing FDM materials that makes it as close as you can get, about within about 10% to injection molds. And that deals with the fatigue problem.
What did the servos cost?
Those are Blue Trail SER 2010s, I believe. They're really just running, big hobby servos inside of a waterproof case.
Yeah, high-tech T95, 24 SW.
They're still priced at about $375 each, I believe. But for the reliability we've seen between the sub and the other team, and like our college folks, for Arsenal, it's just been pretty good.
So is that their like COTS connector whip coming out of it?
So we used one with a cobalt and one with a wet link penetrator, just so that we went with the default configuration for our first servo, just because we wanted to get it sooner rather than later and just have it work. We were tired of stuff not working, and despite some in-house solutions that looked promising, nothing really worked out. But the wet link penetrator was a cheaper solution that there wasn't too much of a trade-off for our application, so I wanted to go with that.
So what percentage of this ROV would you say is new to Israel?
The whole frame is actually new, that was all
Oh, okay.
downsized.
Yeah, and that was swapped out, like the day before we took on the road?
Well, I built it.
No,
put everything on
it was-
it.
the frame was fully
It was
done.
fully assembled.
It was fully done one day before that.
Yeah.
Every single tool was new, all the motors are new, we've got at least one new camera there. We've updated these from our previous disregards, which were a lot more inefficient, so we've gotten better power, twice efficiency out of that. On this new.
We also moved away from we used to have bus bars here, instead of this, power distribution board. This seems to be working a lot better, a lot more clean, we're not constantly snagging wires on things.
And if we did have the power from that, probably would have single fit this one.
The two, the acrylic two?
I do have pictures. So,
Your enclosure?
Microscopic fraction.
We reached out to the material science professors to figure out what we were seeing, because we hadn't seen anything like it before. It's known as crazing, and it's sort of like, it's just like a fatigue-induced compression fracture.
I believe so. It's very complex area.
Yeah.
And the thing is, like, it didn't, in the moment, never seemed crazy, it worked fine, then we had that tube for 2 years.
Yeah, 2 years.
And it was fine until probably like, a month out from when we realized it was happening, we were just like, it's just like, scratches or whatever, and then we looked closer, and then, we found out there was like this like glass patterns in there.
I'm pretty sure I just went into this and I looked up tube and it was like.
So is that a COTS enclosure or is that?
This is a video product, or
Yeah.
E-plastics.
Oh, the E-plastics.
Yeah. You can probably pull a picture of crazy in general, and but from talking on, the professors and just trying to do research online, not necessarily a fatal flaw, but we didn't really want to take the risk of such an implosion.
So how much time do you have in the water since you just got it together?
Well, so we've actually, since putting the power board in, probably close to 10 hours actually.
Okay.
It's been a lot.
This is a service level.
Oh.
This is microscopic, let me look at it, and yeah, it's interesting to figure out that acrylic isn't very.
Fully localized to
Yeah.
just the
strap.
You said you're very defined.
Oh yeah, that was the most intriguing part about it.
Spread.
But in terms of the time, frankly, it is kind of lucky that we kind of went away from hardware because I'd actually never run on it. It was these guys because it was after I left after graduating. So it was the power system that I've trained on and I've had hundreds of hours on over the years I've been here. It's already.
So are you keeping the straps?
Yes, right now,
Very
we've
like
just done better about making sure it's not as much, and we haven't noticed any issues yet.
Probably pretty young.
Yeah.
Alright.
All right.
Yeah.
Take it as is, smoke.
It's good for you know what you're getting a lungful.
So unfortunately, I haven't had the smoke inside, only outside.
A couple months.
Yeah.
Well, good luck in your next pool run.
Yeah.
And I'm curious to see the collaboration.
Yes.
Guitar.
Yeah.
We're, that is our work.
That sounds like what we're
After,
doing.
yeah. That's our work.